Hello everyone, I Gitanjali Khamra Raghuvanshi, Assistant Professor from Department of Computer Applications at BSSS College, Bhopal. So today we are going to learn about a very interesting topic, that is a program development lifecycle. So let's begin. So our today's outline is programming concepts, program development lifecycle. Then we are going to cover few steps in program development, then a characteristics of a good program, development of an algorithm, flowchart, then what all notations we use to make a flowchart, example of a flowchart, and iteration, recursion, and the looping. Let's start with our first topic, that is programming concepts. So, my dear friends, what exactly the programming concepts are? So, first of all, we should know what is the purpose of programming. So, here I have mentioned the purpose of programming is to automate the process. Yes, we make a program to process the things automatically. Whatever the instructions we have given, according to those instructions, it performs the executions automatically. So, the practice of programming is one of teaching the computer to do something. This is all about the programming concepts. Let's proceed with the program development lifecycle. So, here you can see that we have a life cycle of a program where we start with defining a problem. The very first stage is problem definition, where we actually define a problem. Then we proceed with the second stage, that is a problem analysis. It means that after defining a problem, we have to analyze it, we have to analyze the reasons behind it. Then we proceed over the third stage, that is algorithm development. So we develop an algorithm to resolve that particular problem. According to developed algorithm, we start doing the implementation, where we do the coding part and as well as we perform the documentation. After coding, we have to check that code whether it is correct or not. So we reach to the fifth stage, that is testing and debugging. After debugging the program or after doing a final check, we have to do the maintenance part, that is the last stage of our program development life cycle, which ensures us that program is doing well. So this is all about our program development life cycle. Let's proceed with the deeper explanation of these steps. Here you can see that I have made some alphabetic quotations for each of the stage of program development life cycle. So let's begin with the very first step, that is analysis. So analysis basically deals with the computer user that must figure out the problem. So we have to analyze the problem first, then decide how to resolve it. So the very first stage says that we have to analyze the problem, then only we can resolve it. After analyzing, we have to go with the design phase. That is where we actually design a flow chart to resolve the problem. So under this design phase, we actually make a flow which contains the program, or you can say this step will break down the problem into different modules. Accordingly, we can reach to each and every module step by step and we can resolve a problem. After designing, then we proceed with the coding part. Whatever the design we have made with the use of flowchart, we start implementation of it, where we do a coding. So coding actually can be done in different programming languages, where we write a code to resolve a problem. After doing a coding, we have to test our code. So we proceed with the testing stage. So this testing actually deals with the debugging process. If suppose your code contains any of the bugs, so we debug it. It means that we are ensuring whether the program is running correctly or not. Then at the end, our final step is a maintenance. So this maintenance is the final step where we actually prepare our entire documentation. This documentation contains each and every step which we have performed in the program development lifecycle. Now let's see some characteristics of a good program. So here I have mentioned some characteristics of a good program. Now let's see one by one. So here you can see that a program, when we call it as a good program, should be portable. It should be maintainable, means it should provide us some maintainability. We can easily maintain it, as well as we can easily port it from one device to another device. Then it should be reliable enough, means you can easily trust on your program that yes, after debugging, it will definitely provide you the good results. It should be readable, means whatever the program you are making, it should be readable enough. It should be understandable by the programmer. It should contain some structure. There should be hierarchy of the functions which we are using in the program. It means that it should be structured enough. It should be cost effectiveness. It means that it should not contain much memory so that it can provide a better cost and better performance in different terms. Then it provides a generality. It should have a proper documentation, which means that if any unknown person is reading your program, so after reading the documentation, he should easily understand that what exactly the program is doing. Then it should machine independent. Yes, it is not like it is going to run over a single machine. It should be independent from the machine, means it can run on different machines at different time. And the second last is flexibility. Then it should be efficient enough. So all these are the characteristics of a good program. After seeing all these characteristics of a good program, now let's see what exactly an algorithm is and how we develop an algorithm. So here I have mentioned few steps with the help of which we can easily develop an algorithm. So before developing an algorithm, we should know what exactly an algorithm is. So algorithm is basically a step-by-step procedure, or you can say these are the key steps which we actually follow to implement any program. So these are the steps. First of all, the first step says, obtain a description of the problem, which means that you have to describe the problem before resolving it. So according to that problem, we design a solution. So first of all, we describe the problem. After describing the problem, we have to analyze it. So the second step is analyzing the problem. Third is, after analyzing, we have to develop a solution for it. So third step majorly emphasizes on the development part. Then after developing, we have to refine our algorithm. If suppose any modifications are required, so we are going to perform those modifications in our algorithm and we are going to refine it. So the fourth step is about refinement. And the last is reviewing. Whatever the algorithm we have made, it should be reviewed first before the implementation. So before moving towards the implementation, we should review our algorithm. So these are the steps which we have to follow while developing an algorithm. Let's proceed. So flowchart is basically a graphical representation of step-by-step procedure, where we say that a flowchart is a diagram that describes a process or the operation that we are going to perform. So basically here a flowchart says that a process starts with a start point, and whatever the operations we are going to perform it, we mention it with the notations of a flowchart, and then we end it at the finish button. So here we'll tell you about the notations of a flowchart. So the very first notation is a terminator, which is depicted with the ellipse shape that is presented here. So basically, a terminator is a symbol that represents the starting, or you can say the ending point of the system. So while you are making a flowchart, then you actually require this terminator just to show from where you are starting your flowchart and where you are ending. So we use a terminator to show the starting and ending point. Then we have a process box. This process box is a rectangle in shape. This particular box indicates the particular operation, means whatever the operations you are going to show in your flowchart, you have to take a rectangle box to depict it. Third notation which we use is the document. So this particular document is a shape with a tilted corner in the rectangle you can see here. So this particular shape is used to represent the documentation in form of printout, in form of soft copy documents. So, or you can call it as a report. So this documentation or a document symbol is used to represent the report. Next we have a decision box. So this decision box basically represented with this diamond shape. This decision box tells you now which option you have to choose or which you have to not. So here you can say this diamond indicates the different possible situations, or you can say the sub-processes which you can choose further. Next we have few more notations here. That is the data and flow. So basically this data is represented with a parallelogram shape, means a rectangle with little tilted shape. So this parallelogram actually represents the information entering and leaving in the system. Means whatever the information is entering into the system and whatever the information is leaving from the system gets represented with the help of this data box. And the last is your flow. So this flow is basically a line with an arrow which tells that from where to where the data is flowing. So this is all about the flowchart notations. Let me show you one example to make a flowchart. So here you can see that I have mentioned one example where I am going to add two different numbers. So here you can see that we are starting with this ellipse shaped box that is called as a terminator. So basically I told you terminator is used to show the starting point and the ending point. So here we have used this terminator symbol. Next we are going to take the input A and input B. Then we are going to add these two values stored in the variables A and B. So basically, for example, if I have taken 529 in the A and 256 in the variable B, so we are going to add these two values and we'll get the sum which is going to be stored in the variable sum. So with the help of this document box, we are going to print our output with the help of this sum variable. So here we get the output that is 785, which is represented with the variable used as sum inside the document box. And here we have received our output, so we'll end it with the help of again a terminator. So this is a very short example of flowcharts. I hope you have understood. So with this short example, I tried to make you clear with the concept of flowcharts. Now let's see the last topic from our today's outline, that is iteration, recursion and looping. So let's see. Here you can see I have mentioned a very easy definition of iteration. Iteration is basically a repetition of code, or you can say a repetition of block of instructions that is written in the form of a code. So whatever the number you have provided to repeat that code, till that number of times the code will repeat. It means that once the instance or the status is encountered, it will stop there itself automatically. So when the first group of instruction is carried out again and again, so it is called as iteration. Next, we'll see the recursion. So here is the recursion. Basically, it is a process in which a function call itself as a subroutine, which means that we are not going to give any specific instance till which the program has to repeat, but here the program will repeat itself, which means that whatever the functions we have mentioned inside a program, that function will call itself as a subroutine of that program again and again. So this is what this particular recursion allows the functions to be repeated several number of times, since it calls itself during its execution. So function that incorporate a recursion is called as a recursive function. So today we have learned about the program development lifecycle, development of an algorithm, concept of recursion, iteration, looping, and the concept of flowchart. I hope it's clear to everyone. Thank you and have a nice day.